Welcome to MyProjectBazaar.com. Now we are going to discuss about the project extracting fetal ECG from a single maternal abdominal record. Now we are going to discuss about the abstract of the process. This process introduces a bi-level technique for extracting the fetal ECG from the single abdominal record. The proposed method in the first there extract the estimate of the maternal ECGs by processing the abdominal signals through the smoothing filter. The estimated maternal ECG is then nonlinearly assigned with the abdominal sign using the polynomial networks to extract the fetal ECG signals. Results on the semantic and abdominal ECGs data shows the proposed method can extract the fetal ECG with singular quality comparable or better than the extracted by multi-channel based methods. Hence, in this method, it will be working fine to extract the maternal ECGs from the abdominal regions, and then it will extract the fetal regions separately. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The flow diagram consists of the modules such as the input signal, pre-processing, feature extraction, classification, and finally performance estimation. At first, the input signal is taken from the dataset. The dataset is the collection of data which having the several kind of signals. So we have to take any one signal from the dataset. After the collection of the signal from the dataset, then we move to the second stage of the project, that is the pre-processing. In this pre-processing, actually we have two kinds of pre-processors there. One is the major one, that is the Butterworth filters to remove the noises present in the signal. Once the Butterworth is applied, if the input image is the noisy signal, so it will be removed by using the Butterworth filter. Then the signal limitation. This is the primary step only. So hence we are applying the signal limitation. Whether the length of the signal is too long, it will limit the signal length. After the signal limitation, we just move on to the feature extraction, that is the third stage of the project. So after extracting the features, we are using the peak deduction method to extract the features from the signal. So peak deductions will extract the peak portions, then those peak values will be represented as peaks. So after extracting the features, we just move on to the classification. In this classification, obviously you know it should have to classify whether the input signal is affected or not. So if it is a normal signal, it will indicate as a normal, or else it is an abnormal signal, it will indicate as an abnormal. So after the estimation of the normal or abnormality, so we have to find out the final stage of the process, that is the performance estimation. In this performance estimation, we have three kinds of performance, that is the accuracy, sensitivity, and specificity. By using these three parameters only, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure of the process. At first, open the MATLAB 2015B and change the current directory. If you want to execute the file, just right click in the main_GUI.m and select the option run. After the selection of this one, the new GUI will be open. In that user interface, you can see the several push buttons in the right side for the controlling access, and then the several axes in the left side for the display purpose, as well as the tables and edit books will be there. So first of all, we have to click the button input signal. After clicking the button input signal, we have to enter the signal number. So I have entered the signal number as 1. Now the corresponding signal is shown in the axis 1 with the title of input signal. After the selection of the input signal from the dataset, we just move to the next step of the process, that is the pre-processing. So in this pre-processing, obviously you know about the pre-processing, we have to remove the noises from the signal. So in this one, we are using the Butterworth filter to remove the noises from the signal. So after that, the Butterworth filter signal is like this, then the denoised signal is looking like this. After the denoising, we just move to the feature extraction. So in this feature extraction, we have to extract the features from the signal. So you can see the difference between the signal of denoised ear and then the peak detection one. So in this peak detection, not only the peak will be detected as well as the valley regions will be detected. So the red color dots indicates the region of the peaks, then the green color regions indicates the valley regions. So peak regions represents the topmost portions, then the valley regions indicates the bottommost position. After extracting these two features from the signal, those values are plotted in this values in this table. After the extraction of the features, we just move to the classification step. In this classification step, we have to find out whether the input signal is normal or abnormal. If it is a normal signal, it will show the message box like this, normal signal, or else if it is an abnormal signal, the message box will be indicated as an abnormal signal. This is the values which represents the train features. Here we have around 32 signals in the datasets. So the features of that 2 signals are represented in this table. After doing the classification, we have to find out the performance of the process. The performance will be estimated based on the 3 kinds of parameters, that is the accuracy, sensitivity and specificity. Those values are shown in this message boxes like this, 96.6 for accuracy. Now this is also shown in the table as well as in the graph format. Thanks for watching this video.